Hi guys, welcome to Dogen Sprint 22, Cine Teatro de la Mib. So this was a bit of a sort of a weird sprint really. It started off with us taking quite a long time off, and then it ended up with a couple of weeks of working on it full time, which meant that we had quite a lot of time to focus properly, which is not something that happens very much when you got a part-time sprint really. And because of that, we decided to tackle one of the kind of thorny problems that we had, which was related to variability. So the stories you see and the stories you saw on the release notes are all connected to the cleanup that we did to the variability model. What we'll do is, because this is not really a sprint where we can talk too much about the features that we worked on, the best thing, or we can't exemplify too much, the best thing is probably to just explain what it is we're trying to do and how it impacts the models. So what I'll do is I will, for the first story, split the templatized and non-templatized variability meta-model elements. We'll just have a quick look here at how things used to be versus how things are right now. What I'll do is, very quickly, let's just hop over to Git and say we grab a model, so project models, and so a good representative model of this problem is probably generation C++. So if I just go up to the state of this model in the previous sprint, which is what we got right now, and then if I just open it up in Dia, so as you can see here, this is the model as it stood in the previous sprint. Now this should give you a very good impression of how things were. Oh, actually, for good measure, let's also open up the profiles model, because we can see then the features in place as well. So if I do exactly the same exercise, but for profiles, which you can see is just here. Yeah, oops, I meant to say 21. And now, similarly, if we just open up hidden and all files, and then profiles version 21. Okay, right. So so let's quickly see what we mean about these profile templates and the feature bundles. So when it comes to profile templates, the first thing you'd see, of course, is that we have all these things here called profile templates. Profile templates, everywhere. The stereotype is profile template. Now, in reality, of all of these profiles that you see here, the only one that's really a profile template is this chap here. And the reason why is because, as you can see here, we have just the name enabled. The idea is that this is not really a field, a specific field, but it's actually a template of a field that's going to be executed against every single entry in the kernel. So in this particular case, the kernel is MASD and the backend is C++. So for every single entry in C++, this will instantiate. So all the archetypes that exist in C++, all features in C++, and so on, they will have the stereotype set to false. And because we chose the template kind of facet, that means that we only do this for facets. We don't do it for archetypes. So that is the only template. Everything else is actually just a regular profile. In other words, you're just creating a canned set of configurations that you're kind of trying to label and you're trying to reuse. And of course, you are already familiar with the uses that we got of profiles. So for example, handcrafted is a profile that we got where we start by disabling all facets, which you can see is here. And then after that, we can then enable specific facets, like for example, for types, we can enable via typable. So really, the name profile template was very misleading, because we don't really mean a profile template in the vast majority of cases. What we really mean is a profile. And occasionally, we do mean a profile template, such as there. So what we did in this sprint is we spent quite a fair bit of time trying to clean this up, and we changed the way these types of model at the meta model level, such that we also changed the color scheme, as you can see here. such that the profile templates and the profiles are actually now distinct meta-model elements, and we can clearly see when we're using a profile template and we're using a profile. Now, interestingly enough, more due to accident than planning, we can still do what we did before, which is to say we can link a profile against a profile template. So for instance, handcrafted is still linked with the profile template, disable all facets, which is pretty cool, because that basically means that we can create a profile template to span a very large area of the of the physical space, but then we can just connect back to that and set the little features that we want to set on the profile. So that was pretty cool. It's actually not really something we thought about too much, but it kind of just worked. So it's cool. Now similarly, on the other side of profiles is facets, because profiles is actually making use of a feature. Sorry, I don't mean facets, I mean features. So profiles are making use of features that we defined, and quite a while ago we added code generation support so that features were generated by Dogen itself. Now we had a similar problem with features in the sense that whenever we define the feature, we define them using feature bundles, so at least it was not a feature bundle template, though of course now we had a sort of an asymmetry where one is called feature bundle template, the other one is called feature bundle. But nevertheless, it was entirely possible to define a feature bundle using a template. So for instance, you can see here, this chap here is defining a set of templates, and the templates here are defined against a facet. Now it's also possible to define the templates at the field level, which is not a very good thing, but it's possible. And of course it's also possible to define a feature bundle that does not have templates. So these are actually template kind. Actually, template kind should be instance here. I think it just defaults to instance actually. But the idea basically is that these fields here are also templates. They just tend to be template of kind instance, which is the default value. Now, again, we didn't really like this. It's not nice that you're using certain things as templates, certain things as not templates, and they're using the same meta model element, and this all becomes a little bit confusing. So with this tidy up, what we've done now is that we've distinguished things that are feature template bundles, and the emphasis on templates, and those have their own meta model item element, and feature templates for the feature bundles, which also have their own meta model element. Now you can see we can distinguish between the two. So we have a bit of noise in the background. Let me just pause for a second. Okay, it seems like things are calmed down a bit downstairs. Hopefully there's not too much noise in the video. So as I was saying, this split that we've done of things that are actually really templates and things that are not templates made the meta model much clearer. And that also means that we can now supply the bits of data where we need, rather than all over the place. And what I'll do now is I'm going to skip over to the next story because they're really truly very connected. So as you can see, in the past we had this notion of a template kind, and the template kind was basically kind of more or less hard-coded really. We had a template kind which was given by either a facet or a backend or an archetype and so forth. And that actually stems from the fact that the variability model, so what I'll do is I'll just, again, as we did for the other models, let's just quickly hop over to the state of the variability model in the previous sprint. And let's open it here. Just need to yet again change the supported formats and change this to variability. Here we are. So the variability model, as it stood at the previous sprints, what it did is we had this notion of a location, which is here, and that location came from the sort of the archetypes model. And the archetypes model, as it was called then, was basically providing you with a point in space, in physical space, which was containing the kernel, the facet, and so on. And so that wasn't too bad, because at that time the archetypes model was actually quite a small model. I mean, probably should have opened up all these models before I started, but there you are. In fact, we can't even do that because we can't travel in time because the file has been renamed. But nevertheless, so the role of the archetypes model, I mean, I can show you how it looks like now by looking at the physical model, which is this chap here. And what the archetypes model used to have is this thing that we call a logical location, which used to be called just the no, actually the location, sorry. And you can see here it's got the kernel, a backend, and a facet, and an archetype. And there was a few other things in this model, but it's a very, very small model. Now, as you can see, it's much, much bigger. So the archetypes model, as it stood then, provided the variability model with this notion of a point in physical space. And it was through those points in physical space that we used to iterate. So you can see here, we had the notion of template kind. The template kind was then telling us where in physical space, what region of physical space should we iterate through of those points obtained by their location. So whether it's archetype or facet or backend. So it's kind of very tightly coupled, very tightly bound with the physical model. Now, as the physical model changed its role from the plain, simple archetypes model to this really comprehensive physical model that we now have in this sprint, as you can see, it's pretty comprehensive now, just lots of types in it. We didn't really want the physical model to be coupled to the variability model, especially not because of this tiny little thing which was just to do with the templates. So what we've done instead is we created this notion of a domain, and a domain in the math sense really. It's just basically a set of elements. It's just some kind of set of elements, in this particular case strings. And now what we do is when we're trying to instantiate a template, we just instantiate the template over the domain. And it's someone else's job to provide us with all the domains that we need to instantiate. So in this particular case, all we need is for somebody to give us the name of the domain, and for us to have that name of the domain supplied somewhere. And once you've got the name of the domain, in this particular case is being supplied via this context you see here, then we just iterate through those elements and we just instantiate. Which means that there is no longer a dependency between these two models, and it also means that life is much easier now in terms of instantiating templates, because if I take this model here, I can just supply my domain name here, and that domain name could be pretty much any of the available domain names. As you can see, the release note for an exhaustive list of types, and that will then change the instantiation. And if in the future we add more domains that are not necessarily coupled to the physical space, physical dimension, well, the variability model doesn't particularly care. It just it's up to you to just give it a list of things, and it will just instantiate that field over that list. And this is actually a much easier way of implementing instantiation, because we don't really have to have all sorts of recursion and all sorts of crazy sort of logic like we had before. With domains, it's actually really simple to instantiate templates. So that was a bit of a win. We also tried to simplify how feature bundles and profiles are defined. So if you look at the previous version of the profiles model, you can clearly see, even if you just do this sort of on visual inspection, you can clearly see there's a lot of redundancy here. So we have MASD.generation.decoration, .enabled, MASD, and so on. And the other thing as well is, because of how things used to be aggregated, we were actually doing a bit of mixing and matching. So what we've done now is we created this notion of, well, colors have changed as well, but created this notion of a prefix, the prefix, a variability prefix, and this could be supplied at the top of the profile or the bundle, feature bundle, and then all elements inside of that bundle will belong to that profile. Now, of course, it would be nice if the name of the class, as understood by UML, was actually the prefix, but that is not possible because we've already done quite a fair bit of logic around names of classes and so forth, and it's not possible for those names of classes not to match the package that they are contained in. So in order for this name to match the prefix, we'd have to have a namespace called MASD, called decoration, and so forth. So that was not very practical. So instead we separated this concept and we created the notion of a key prefix, and you can supply it here, and then all the elements defined inside of that profile or bundle will then be assigned to that prefix. And as a side effect, as you can see here, things became a bit neater because now we're no longer mixing and matching like we were before, because now we have to think about slightly about how we're packaging these profiles. So now we created slightly more better named profiles, and then we use inheritance to couple all of them together, multiple inheritance in this case, to couple them together into a common base profile. And we don't have to use this prefix all the time, of course. For certain cases, like where we do want to mix and match, and you can see a couple here, we do use full names. And we don't really want to start making too much use of this prefix, because it should really be obvious when you look at a profile what that profile is about. And if it isn't, then probably haven't done the right job. So for example, we probably should have called this a base C++ profile, really, because the idea here is that all of these things here are connected to C++. The prefix is not inheritable, so you can define it in one profile, and then you have to redefine it again on everyone that inherits. And that simplified, as you can see here, simplified dramatically the way these profiles are defined. So a lot less information now. Things are much more obvious now. So that was also quite a win. An additional feature that was also a requirement for Dogen, which was really improved things quite a lot, is the ability to have templates with default overrides. So you can see here, for every single facet that we've declared here, we have a whole load of fields that we had to declare manually. These are directory, postfix, well, mainly directory and postfix. The only reason why this is done is because in this particular case we needed to override the default value. So for certain cases, such as for example directory here, we need a directory to be called types, because the facet is called types, and here hash, because the facet is called hash, and so on. And it's not always the case that the name of the directory is the name of the facet, though often it is. And so because of that, we had to redeclare all of these types instead of relying on a template. With this new release, we don't have to do all of that anymore. We can just hop over to, say, the generation model. And here you can see in fact, to be honest, this has moved over to the physical model, now that we are dealing with physical aspects in the physical model. So we can now declare a directory as a template, simple template, and then, of course, the template will expand over the domain of mass.facet, so this is for every facet. And then, as you can see here, we have a number of overrides, and these overrides latch on to the end of the key, so in this case CPP templates and so forth. And what this allows us to do is to declare the facets, declare the feature just once, and then declare different overrides for the default value. And now, instead of having all those types as we had before for the features, you can see here now how simple our facets now look. There's nothing actually being declared here. And the generation model for C++ and C#, is much simpler now. This is all part of the work of simplifying the generation of the code generator. So this really helped. The last option, I believe, the last feature that I'll talk about, code generation feature, is the dump specs. So I'll just run, so just do minus version to make sure, well, we're running latest here, but so you can see when I do a dump specs, as I do here, what it does is Dogen basically dumps lots and lots of internal information, similar to when you do a dump specs in a compiler, at least on GCC. Not sure if Clang supports that. So what it does is it enables you to see how Dogen, all this sort of dynamic data that we kind of inject into Dogen at runtime, it tends to give you a view of all of that. So for example, in this particular case, you can see that the version of Dogen supports 2 injectors. I mean, we only have 2 injectors at present, but in the future this list will extend. It supports 2 injectors, as you can see here, dia and JSON. And we have support for only one conversion, which is from JSON, or into JSON. And then we have two generators, which is C++ and C#. And then every single feature that is supported by Dogen is then listed, and this is after template expansion. So you literally see every single feature here. So if you at some point want to know what's available, you can just do a dump specs and it'll tell you. And the features also tell you where they bind. So the binding point, as you can see here, besides of course having a description. They tell you where they bind, and they tell you also the type of the feature, so you can you know what values are supported. So dump specs is really useful because we keep on forgetting what's available, and it also is of course grabbable. So if for whatever reason you want to see what's available in terms of variability features, of course you can just grab. That then gives you all the keys that are connected to variability. So yeah, this is let's just repeat that with the presentation here, but that's the last thing. So this was a very productive sprint. I mean, it resulted in a ridiculously large amount of changes to user-facing changes, which is very uncommon to Dogen normally. But the main reason why is because we had to do this core refactoring of variability, and because of that, that then moved a whole load of things. This was not exactly ideal, but this is what happens in a sort of an unstable code generator, sadly. So not much we can do. We're not going to stop progress just to avoid breaking backwards compatibility. So this is by design, really. At some point, when you get to 2.0, we will stabilize the ABI. But until then, sadly, we're going to have a lot of breakage. So that's it for this sprint. Thanks for watching.